Last session I was explaining about OOPS concepts. Okay, so OOPS we saw it programmatically. What OOPS we saw yesterday, we saw it programmatically. Okay, programmatically in the sense like how you do encapsulation in a class. If you want, you can do overloading, and once the class is ready, what you do is you start creating objects and you start calling them methods, and you'll start getting the output. How you get the output, we don't bother. That itself is called as abstraction. So that is from practical point of view. Theoretically you have seen, like in colleges also yesterday as I told you, like you want to know OOPS according to your own theory. So that also I'll explain to you. Okay. See, what happens is in real world. In real world, if you see, this OOPS concept has been picked from real world. OOPS, what we are learning now, has been picked from real life concepts. Okay. In the world, everything is an object. If you see in the world, everything is an object. Okay. And what happens is, and these objects, they encapsulate complexity. These objects, they encapsulate complexity. Like I'll tell you an example now. TV. TV is a good example for encapsulation. The TV is having so many things inside it. Okay. So then television. Okay. So it is having so much of encapsulation. So what happens is it is encapsulated. So why they are encapsulating is they see, after encapsulating that thing, what they do is they generally give you a mechanism to work with that complexity. That remote they give. So using the remote, you can work with the complexity. But why did they first of all encapsulate? For easy maintenance. Okay. So the thing is, see, so many things are encapsulated like that. Even if you want the time, if you want to see the time, I'll have the watch. In the watch also a lot of complexity is hidden. Now to work with the complexity of the watch, they are given one key. Okay, I can change, if I want to change the time, date or something, I can use the key and I can work with the complexity of the watch. So there are so many things in the world, and for all these things, what happens, things have been encapsulated. All these things have been encapsulated, and they give a mechanism to work with that complexity. Like example, as I told is, like for the key, for the watch they give the key. For the TV they give the remote. Okay. Similarly, as you know, the car, you say, the car has an engine. The engine is totally encapsulating many things, complexity. Okay. To work with that engine, what they do, what they give you is one gear. First gear, second gear, whatever you do. So automatically what happens? It will work with the internal mechanism of the engine. So for all the complexity, you can notice they always give a handle. We call it as a handle to work with that complexity. The handle to the watch is key. The handle to the TV is remote. The handle to the engine is gear. Like that, for all the complexities, they give you some handle. And you cannot work with that complexity without what? Without the handle. I'll have the watch, but without the key, what will I do now? I'll have the TV without the remote. I cannot do anything. I'll have the engine without the gear. I cannot change anything. So always, when complexity is there, to work with the complexity, a handle has to be provided. Okay, so that is one interface to work with that complexity. These handles are nothing but one sort of interface to work with that complexity. This is real world. And once this complexity is ready, next what we do is we just start using it. Now if I want to watch the World Cup match, I'm not going to sit and invent a TV now. Blindly what will I do? I'll get the TV. Okay, I'll get the TV and I start using it. So man is adapted to this. He doesn't want to invent what are already existing. Means if something is there, we directly try to use it. We don't try to invent it. Understood now? Because if I start inventing on TV, it will be, next World Cup will come. Next World Cup will come. And by the time you invent a TV, all World Cups will be over only. Understood? So what happens is, when things are ready-made, we have to use it. We should not go on inventing from the scratch. If nothing is there, then you can invent a new thing. Same way, if I want to see the time, I can't go on inventing a watch. Okay, if I want to go from one location to another location, I want to fly. So I cannot sit and invent an aeroplane. So what are things existing? We start using them. This is the tendency of a human being. This is the tendency of human being. Okay, similarly in Java also, what happens? We have classes which are ready-made. They also encapsulate many things like this. And these classes are actually called as engines. Okay, TV is one kind of an engine. Watch is one kind of an engine. Okay, a car engine is also one type of engine. So to work with this engine, they always give you what? One handle. And you cannot interchange. That also you notice. You cannot interchange. Can I use the key of the watch to change the gear? Can I use the key of the watch to change the channels or increase volume, decrease volume, something of the TV? I cannot use this key to handle the TV. I cannot use this key to handle the gear. Similarly, I cannot use gear to change the time here. I cannot use the gear to change the channels and all that. So vice versa, I can't use. What handle has been designed for what? there only you have to use it. Things are like this. Okay, Java adapts the same thing. Whenever you want to write any code, no, that is complexity. We start hiding it in a class. We start hiding it in a class. Okay, so then what happens? Somebody when it writes it, it is not physically existing. Then what we do next? We create the object, we bring that into existence. But after creating the object, we bring that code into existence, yes we know. But to work with that object, we need the handle, no? The reference variable is the handle to that object, or the reference variable is the handle to the complexity. So you cannot work with the object without the handle. Object is nothing but what here? We can call it as complexity in simple terms. In simple terms, see, there are many definitions we can give for an object. So, but first thing is, see, object is physical existence. Okay. Second thing we can say, or we can put this as primary. It's an instance of the class. It's an instance of the class. An object is an instance of the class. Second thing, it's a physical existence. Third thing, it contains what? Complexity. Object is nothing but containing complexity. You write your logic, no? Whatever methods you write, that is only complexity. So why are you writing the complexity in the method? To reuse again and again. See, in the TV also, so much of complexity has been hidden. Why they hide it? So that some others can use it comfortably. Similarly, when we write a class, we write methods inside that. Why do you write a method inside it? So that others can use comfortably, not only you. Others can use it comfortably. That's it. It contains complexity. Okay, fourth thing. It contains complexity, or you can say it's an engine. Many words are there. See, one author will be using one word to explain you this concept. Okay, but meaning is same. End of the day, because see, from one dimension they'll explain to you. Till now I had not used these two words. Now when I start relating this code with real world examples, automatically I have to use these two words now. To make you understand real world examples, these two words become very important here. Understood? So real world examples means which one? TV, engine and all that, they are real world examples. Class is similar to that. It is an engine, it encapsulates everything. Okay, once it encapsulates something, then what we do? Whenever I want to use it, I'll create an object of it. And after creating the object, we start using it. You work with that complexity. Which complexity you want to work, you decide. There are many methods now. You call M1 method, it will execute M1. You call M2 method, it will execute M2. That is nothing but working with complexity. You have a TV, you have a remote. In that remote, so many options are there now. Volume, channel changing or whatever, tuning, so many things are there. You want to work with which complexity of the TV, you decide and press that remote button. Automatically that thing gets affected. Similarly here, you create an object, you call the method. Now you are working with the complexity. There are plenty of methods. You can call M1 method, means supposing there is a class A, and in class A there is M1, M2, M3, M4 method. We can work with any complexity now. You can call A is equal to new A dot M1, A dot M2 or A dot M3, like that. It's nothing but you are working with the complexity. But to work with the complexity, what do you need? You need a handle to the object. So you need a handle to the object. Without the handle to the object, you cannot work. That is what we are learning yesterday. I told you now, see, this is what we saw yesterday. Class demo, we created the object, new box. It's something like you have got the TV without the remote. Valid code. That's the meaning of this. You got the TV without the remote. You got the watch without the key. You got the engine without gear. Now it is useless. So to work with that complexity, what I should do? I should have a handle to that object. So the reference variables are only actually called as handle. The reference variable itself is called as what? Handle to the object. Are you following now? The reference variable is nothing but is a handle to your object, or it is the handle to what? Complexity, or it is a handle to engine. Anything you can say. One point, second point, it is a handle to complexity, it is a handle to engine. Anything. So that is why we declare reference variables. How you declare? See this, box B is equal to null. Initially you got only the remote, TV is not there. In this line what's happening? Remote is there, TV is not there. Understood? Remote is there, TV is not there. Here what happens? TV is there, but you are not giving the control to the remote. So if you want to give the control to the remote, do only this much over. Understand now? So this is how it works. So I am just comparing it with real world examples because you are addicted to this. And no doubt, things are becoming more clearer. If you learn like this also, things become much more clearer. So box B is equal to null, means you got only the remote. Okay. So box B is equal to null. I have given some null value. Still I have not created an object. Next I will create an object. And that address I will give it to B now. So if you want to work with this object now, box, so this is in the JVM now. This is the JVM. Object has been created. You are having WHND. You might have the constructor. Simply, roughly I'll write it now. You might have volume method. You might have M1 method. All these members can be there. Now we want to work with which complexity you decide. B dot volume. Yes, you can call that method. B dot M1. You can call that method. You are working with what now? Complexity. But to work with the complexity, what are you using? Reference variable. Handle. That is very crucial now. Are you following this now? So to work with the object, you need the handle. Without the handle, you cannot work with the object. Are you getting clearer? If you want, I'll draw this diagram very clearly. See, this is your JVM. In the JVM, memory will get allocated for box. Earlier it was referring to what value? Null. Later on, it will not refer to null. When you allocate the memory, the address of this memory will be given to B. What will be this address? 150 or something. So it will be as is your class. Assuming that class box I have written. Assuming that I have written the class box, you will have the constructor x, y, z. W is equal to x, h is equal to y, d is equal to z. Then you might have the volume method. Then extra method might be there like M1. So all the members will come into existence. Now which complexity you want to work? Work. And which complexity you don't want to expose, that you make it as private. Now all the complexity it's not mandated to expose. Whichever you want to hide, you can make that as private. Same real world implementation only. What you are doing physically for other things, see in real world things are physical, you can understand. But here it is virtual, you have to understand. You are putting everything into a class. That's it. So this is what is encapsulation. And why do you do encapsulation actually? To reuse and avoid complexity. Do not forget that motto. Encapsulation is always now. Why do you encapsulate a TV? So that TV can be used very easily. And to avoid complexity means if I want to see the match, I will not invent it. I am avoiding complexity. I'll just buy the TV and start seeing it. So I am the user now. So for me it becomes reusable as well as I am avoiding complexity of it. Why? Because the TV has been encapsulated. Understood now? So this is how it works. So now see one more thing. If I want, I can have one more class called as test. Yesterday I wrote two classes. So if I want to say new test, yes, test object will be created. But again, how will you work with the test object? Not possible. You need a reference variable. You can write it in a single line, no problem. Test is equal to new test. You are allocating memory, means you are creating the object. You are creating the object as well as you are assigning the address of that object to the reference variable t, valid. Immediately you can do it in a single line. So this is t now. What will t have? Yesterday I wrote some members in t. Okay, x, y. I can have a constructor. pq I took, I think. And I took one method called as show, I think. Anyway, this is how you can write a class. Now I can work with t object also. So now I can work with the complexity of test. So you want to bring what complexity into existence? You decide. Yesterday we wrote multiple classes. One class I wrote for arithmetic. One class I wrote for trigonometry. One class I wrote for interest calculation. So like that many code we'll write. Any number of code you want we'll write. Now which code you want to use? Only create that object. Simply don't create all objects. And that is why what we do is we don't write all the code in a single class. If you write all the code in a single class, what will happen? If you create the object, everything will come into existence. We do not want that to happen. That's why what we do is start classifying logically. Some code in this class, some code in this class, some code in this class. Like now say, in TV you have only the complexity of TV. Does TV have the complexity of watch? No. Does it have the complexity of a car engine? No. Things are separate. Like that they will. One thing means for car they will have one separate engine. Means for TV it's a separate product. For watch is a separate product. Here also when you write classes, you will not jumble up all the code. Okay, some code in one class, some code in one class, some code in one class, like that. But that comes with experience. It's not that you will understand in one day. Okay, what code to put in one class, what code to put in another class, that is experience. But writing logic will be very easy. You'll write the logic, but how to organize your code is very, very important, because the better way you organize, the more it becomes highly reusable. Okay, you put it in one class, and some other code you put it in another class. So now you should know whether to put it in same class or a different class, because if you don't organize it properly, later on usage becomes very difficult. Understood now? And finally, more things. See, I can call here t.show, all this is okay. But can I say new box? No, this all okay. This all okay. But can I give the address to test t? No, you cannot give the address, means reference of box object to test variable. Why? It's similar to real world. I told you very clearly, if you want to work with the watch, the complexity of the watch, I cannot use the TV remote. If I want to work with the complexity of the TV, I cannot use this key. Every product has got its own handle. You have to use the corresponding handle. Only then you can work with that particular complexity. Understood? No? You cannot use any handle to work with any kind of complexity. Can I use the TV handle to work with the remote to work with the complexity of the watch? No. Can I use the remote to work with the complexity of the engine, car engine? Not possible. Same here also. What is so confusing? I cannot use the T handle to work with the complexity of what? Box object. Very clearly they have designed it. And your code is quite self-explanatory. It's not as confusing as what? Other languages. T is a variable and it's a handle of type test. T is a reference variable. Java says T is a reference variable, but we developers should also understand it's a kind of handle. And this handle can be used to work with only test kind of objects. Box B is a reference variable, yes, but B is a handle which can be used to work with only box objects. Don't interchange. That is not possible in real world also, and same way it is not possible here also. As simple as this. So do not try to interchange. So is this concept getting clearer now? Yesterday I explained you this. You can't do this. Yesterday I showed you in programmatical point of view. Today also I am explaining you in theoretical point of view. Why address of one object you cannot give to the reference variable of a different type. It is not possible. Okay, are you clear with this? So, so do you have any questions here? You are understanding OOPS now? Same OOPS we are trying to implement here. Same OOPS encapsulation only we are trying to do here, so that we can reuse our code in a better way. So Java supports OOPS. C++ also supports OOPS. So they are all supporting OOPS and they are all supporting encapsulation. Okay, so they make your code highly reusable. But fine, but Java takes encapsulation, it supports all that very good, excellently it supports. But apart from that, your code is portable. That's one more extra feature what Java gives you. So the class what you write can run in any operating system of the world. That is one best part of Java. C++ also supporting encapsulation. Java also supports encapsulation. Now, what is the benefit of using Java or C++? Portability. Understood? So, this language is not only user friendly, but at the same time, it's having very powerful features. Powerful features. Okay, it's a very powerful language. The data types are rich. Okay, built in so many features are there. Anyway, we are learning one by one. Okay, all this comes to you built in. So do you have any questions here? You understand what's encapsulation?
What is the definition of abstraction in words?
So now I change the time. I'll use the key and change the time. I don't know how it works. That's only abstraction. I am increasing the volume. I don't know how it will increase. And I should not bother also. I should not sit and invent. That is only abstraction. You don't know how things work, but it is getting executed for you. But how is it possible? Somebody has done it for you internally and they have given a handle to work with that. That itself is abstraction.
No, sir, in words.
Abstraction, you read the definition. What is the definition I have given to you? Read. In words, if you want, statements, if you want, why did I give those 4 definitions beginning of the class? Read now. Read. Simply sitting and asking question is not important. What is abstraction? I have given you all this document. Now read it now. What is abstraction? This question is what is abstraction? So now I told you from the real life point of view. Now if you want, you can understand this. Yeah, what is the notes here given here? You can see this abstraction providing essential properties and operations of an object by hiding internal things is called as abstraction. Understood? Providing essential properties and operations of an object by hiding internal things is called as abstraction. Because of encapsulation, abstraction is possible. Okay, when there is no encapsulation, there is no abstraction. Very clearly I have documented it. These are the points and asked you to make a note of all this. Encapsulation, it's a process of binding the data and the methods together in a single unit. Okay, and it's not that you'll understand again in a single class, because OOPS has a history of 50 to 60 years, which you cannot understand in what? 5 to 6 minutes or 5 to 6 classes also. Minimum to understand it you require is what? 5 to 6 months. Minimum duration. Okay, otherwise OOPS theoretically it's over. What your college taught you OOPS? In 2 classes I finished in 20 minutes. What? Car, watch, engine, over. That's what they taught you OOPS, no? Same I taught you. In how many minutes I taught you? 10 to 15 minutes over OOPS. So theoretically if you want we can finish our OOPS like that. But programmatically if you want to understand, it's a big subject. Yeah? So then inheritance anyway we have not seen. Polymorphism. One form behaving differently in different situations is called polymorphism. You'll be seeing this also. But these points are very essential. That's why I asked you to write it down. You might not understand time being. Okay, and every time we go deeper and deeper into this subject, these points more and more clearer they become. These are only short definitions. These short definitions I given you for what? Interview point of view. The short definitions I given you from interview point of view. Very short and precise. Clear this now? Very short and precise. But if you want to implement OOPS, if you want to do all these 4, Java is giving you 4 data types. One of the data type which we are seeing how to implement OOPS is class data type. Class is one data type for implementing OOPS. So Java's data type is very rich. Why it is rich? It can not only store values, but at the same time it can implement OOPS also. And at the same time it is user friendly to work. You don't have the concept of pointer here. Java calls this as what? Reference variable. It's very clear. Java does not use the word pointer. Instead it says it's a reference variable. A perfect word. Okay, and here your reference variable can refer to a particular type of object. It cannot refer to anything of your own. It cannot refer to anything whatever you want. But pointer in C is very difficult. So see, in your user defined data type in C, if you see now, let's compare all the 3 user defined data types. C, C++, Java. C also got a user defined type. Yes or no? It's not required, but just I am comparing so that you can understand how Java is beneficial over these languages. C you have got user defined data types. Which are they? Structure. Okay, union, enum. Okay, we'll take only one now because I don't know how many of you know union and enum. Struct is very difficult to use now. Designing it is easy. Using it, what will you use? Pointer. And in this struct you can't write any logic. When you write struct student, you can only store values. You cannot write a function inside this. Yes or no? In C, can I write a function inside this struct? It gives you what? Int SID correct. String name correct. But if I write void M1, what will happen? It will not support you. It is not rich. And at the same time, it is complicated to use. I'll show you how complicated it is. Okay, because when you complete it, you'll understand. Okay, to reach to this level in C, you take minimum of 3 to 4 months. To learn what a structure is, you take 3 to 4 months. But that's not the case here. We are progressing in Java language very fast. Understood? So we are learning how fast we are progressing means imagine not only we are learning how to store data, plus we are learning at the same time how to implement OOPS also. That powerful means that fast we are moving now. C++. Okay, C++ what does it do? It has got how many data types? Class, subclass, abstract class. Some drawbacks are there here. C++ is not complete object oriented language. Sometimes you can write within class, sometimes outside class. Confusion will start. When to write inside, when to write outside. Understood? It's not a complete object oriented language. Now using a class in C++ is very difficult. Pointers will come out. And still C++ carries the concept of what? Pointer. And on top of that, you design a class, it will run in only one operating system. In C++, if you design any data type, it will run in only one operating system. Now we can take the power of Java now. Java, we have got 4. Class, subclass, abstract class, and interface. They are easy also. If you know class, these are all very much similar. You don't have to worry. Understood? Class, it will help you to store data. Plus you can implement OOPs. Plus user friendly also. You only compare and see now. I am not saying simply Java is user friendly. Step by step if you go on saying, Java becomes 1000 times easier than C++. Now if you compare it with other old languages, assembly and all, imagine how easy it is. Understood? You can take any language if you want, C++ and all that, but actually Java is much easy because it's taking the concepts of syntax of C, but OOPS concepts from C++. But in C++ some OOPS concepts have not been implemented properly. Like one of the example I gave is overloading. Many examples I'll show. Many things have not been implemented properly here, which gives a lot of problems to developers. Java eliminates all that and gives you a very good way of implementing OOPS. Many things it will not support. Deliberately it will not support because it will be confusing for the developers. Clear with this now? So as we progress ahead, you will understand all this. Clear? So shall I clear all this now? You are understanding what is object? Object is nothing but what now? In your words, engine, complexity, your simple words. Technically it is nothing but instance of the class or you can say it's a code coming into existence. You are bringing the code into existence. So organize your code. Whenever you want the code to use, create object, start using it. You want to watch the match, buy the TV. You want to execute some code here, create object. Understand now? You want to see the time, get the watch. You want to use some code here, create object. It's as simple as that. Okay. So that's how Java people are telling. So the code written once here becomes very highly reusable also, and at the same time we have got very powerful way of implementing OOPS here. Very powerful way. Other languages lacked in why C++ failed. C++ was successful because it was following C syntax, but it failed because it did not have proper implementation of OOPS. Some other languages are there. They are having very good implementation of OOPS. I am not saying no. Even I don't know what it is, which language. But the fact is, those best languages which are having the best implementation of OOPS failed because they were not user friendly. So developer will ask for everything now. He wants the best language also, at the same time he wants user friendliness also. Obviously we look like that only. Okay, we look for something which is easy to use also and which is very powerful also. And Java is the one of the language which is like that. Understood? Okay, still it will become more clearer as we progress. You understanding what is abstraction and all now? Abstraction means you don't know how the code gets executed, but it gets executed. And abstraction was possible because we have done encapsulation in a class. So more things we'll start seeing now. So the next topic what I'll be moving is call by value and call by reference. So till now we have seen how to pass primitives as arguments. So now I'll be passing our class data type as argument. So let's see what happens. So you were asking one question, how to return multiple values, how to different set of values. Okay, all that will be possible now if you put your data into one user defined data. So my target is that I want to reach where? How to pass user defined data type as argument. But to make you understand that, I'll be taking one approach now. First I'll explain in a very simple way, then I'll reach to that level. That is my destination. So whatever I teach you now, I'll be my end of the day, my focus is that. So I'll show you very simple programs where you'll understand get all the clarity. Once you get the clarity, same thing I'll do now. What I'll do means first I'll show you locally, then I'll be using it as argument and parameter. You know, local assignments. So first you should understand how do you assign the values locally, assignment operator, and the same thing will happen when you pass arguments and parameters. So first that you understand. So shall I move to this topic now, call by value and call by reference? Call by value you already know. See, it's very simple. Java works on two things: call by value, call by reference. So to make you understand that, again, do not forget this basic. Data types, how many data types are there in Java? Primitive data types, derived data types, user defined data types. User defined, data types. For this it is call by value. Remember this, do not forget. For these two it is call by reference always. Means if you send an array as an argument, you have seen it. It is call by reference. Example for derived is what? Array. Example for primitives, you know, no? Byte, short, int, float, long, all the primitives, call by value. For derived array, call by reference. For user defined, which are the examples? Class, subclass, abstract class, interface. For all this it will be what? Call by reference. So first I have completed class, so I'll show you how to send a class as an argument. After I complete subclass, I'll show you how to send subclass as an argument. After it means any data type can be sent as argument. Simple words. Any data type can be sent as argument. This is true in all languages, not new in Java. In C also any data type can be sent as argument. C++ also any data type can be sent as argument. Java also any data type can be sent as argument. Clear? So I'll be showing you this today, how to send a class as an argument. I completed primitive, I completed derived. And now I'll be moving to how to send class as an argument. So here we are moving to the topic of what? Call by value and call by reference. So when Java will be doing call by reference and when Java will be doing call by value. If it is primitive, it is Java uses both. Java uses both. Call by value also it uses, call by reference also it uses. So it depends on the argument what you are passing. Okay, but before understanding arguments and parameters, first we'll understand how to work locally. Once you are comfortable using locally, then argument and parameters is very much same. Only we assign the value by using argument and parameter instead of assignment operator. Locally what we do is we use the assignment operator to assign the value from one variable to another variable. But when it is in a different method, we use arguments and parameters. Same thing will happen there also. So first you be comfortable with assignment operator and then you'll be understanding what is argument and parameter. Clear? So this example what I give you, it looks very simple. What is so great about it? Okay, now I'll be teaching an example. But later on, that importance you'll understand when you do call by reference. See, in this class there is no constructor. Deliberately I have not written a constructor, deliberately. So we will be initializing these values with the help of what? Dot operator. Okay, generally the better way to initialize is constructor, but I want to show you some concept here. That's the reason I am initializing with the help of dot operator. I want to show you some concept. Are you clear? So let's see this now, how you will do it. See, box B1 or B I'll take. B is equal to null. Box B is equal to null. What happens now? This is your JVM. Null value is there. B is now referring to null. So now what will I do? I'll say B is equal to new box. So since I have not written a constructor, what will happen now when you have compiled? Default constructor would have been added. Default constructor would have been added. Once the default constructor is added in your class, what happens? That gets executed. So one thing is very clear now. Every class has a constructor and an object never gets created without the execution of constructor. Either the default one or the argumented one. And any one of the constructor has to get executed. So here the default one gets executed, the object gets created, and the values in this object would be, since I have not written any constructor, the default values of WHND will be 0 and address is 150. Now this B, which was earlier referring to null, will refer to now what? Will now refer to this particular object. If you print SOPB, it prints the address. What it prints? 150. So now I'll be writing SOPB.W print, SOPB.H, SOPB.D. First understand how to work with the object properly. So you created the object. There are no values in your object. So your object does not have any state. So now if you print, it prints you 0, 0, 0. If you want, you can fill values into your object. How will you fill the values? B.W is equal to 1, B.H is equal to 2, B.D is equal to 3. Everything is perfect and now it overwrites. This changes to 1, 2, 3. But what you have to understand again here is, when I printed B.W, it is nothing but that address.W, 150.W. B.H is nothing but 150.H. B.D is nothing but 150.D. So it was printing 0, 0, 0. Now see, again you observe this. I am assigning a value, but you are putting the value in which memory? 150.W, 150.H, 150.D. So in the address of 150, the WHND will be getting the values of 1, 2, 3. So it is stored. Are you following now? So an object got created, now it's having values, I can use it. Fine. Next, that is one object. So next what will I do? Box B1 is equal to null. Now what will I do? Again see this. B1 is equal to new box. You work with the addresses here, you will understand very clearly. SOP B1 will now print you something called as 250, another address. So here what has happened? Same way, B1 will get created now. This is B1. It will also have WHND, it will also have volume method, because I have said new now. As soon as I say new, what happens? New memory gets allocated, and in that memory the values of WHND will be 0. Same thing, they will be 0, and once the values of WHND are 0 and you print the address, this time it will be having what address? It will be a hexadecimal address. I am writing 150, 250, it will be hexadecimal address. So it will be 250, all this is correct. And if you want, you can print SOP B1.W, what would be the answer? 0. Means in this address it is 0, but in this address it is 1. Notice that. Okay. So it is 1, 0, 0, again 0. It will print 0, 0, 0. Now what will I do? I will fill the values. B1.W is equal to 5, or I will give some values like 5. B1.H is equal to 6, B1.D is equal to 7. So values here will get changed to 5, 6, 7. It overwrites. See now, carefully observe, B and B1 were two variables. For these two reference variables, I gave a value. What type of a value I gave? A reference value. How did I give the reference value? I allocated new memory and then gave the reference value. Agreed? Here also I allocated new memory and then gave the reference value. Agreed? But this is how you assign the values to B and B1. Correct or wrong? Correct. So next, see this, very interesting. Box. See, after assigning, if you print, what will be the values of B1.W? 5, 6, 7. Initially it was printing 0, 0, 0. Now it prints 5, 6, 7. Done. Next, yes, box B2. B2, SOP B2 you print. What it will print? Null. SOP B2 if you print, it will print you null. Work with addresses today more. You will understand how the objects work. It will print you null. Okay. Or if you are not initialized with null, it will give you an error. Variable might not have been initialized. You know this error now. But what will I do now? B2 is equal to B1. A different thing I have done now. What I have done? I am trying to give the value B2. I want to give a reference value. For B2 I can give only what type of value? A reference type of value. So one is I can allocate new memory and assign that value to B2. Or I can give an existing memory to B2. No? Possible? No? Understand this in local. This is how the assignment operator works. It's a very powerful operator. Blindly what it does is, whatever value is there on the right side. What value is there on the right side? it is 250. Whatever the value, whether it is primitive value or reference value, it will not care. If int a is equal to 1, if I write int b is equal to a, 1 will be given. See, if it is primitive value, what happens? Int a is equal to 5. Int b is equal to a means a will give, the value of a is given to b. Whatever the value, it will not care. Same thing happens here. Whatever the value in b1 is given to b2. But what is the value of b1? I am not asking what is the value in b1. I am asking what is the value of b1, of b1. What is the value of b1 important now, not in b1. In b1 values are 5, 6, 7. We are not interested in the values. We are interested of the value. So the value of b1 is given to b2 now. So it is going to have the same value now. So b2 will also refer to the same object. So we have two objects but three variables. Earlier you were unable to work with b2, but now I can work with b2 now, because it is having a address, means it is referring to an object. Earlier b2 was not referring to any object, but now b2 starts referring to an object. Yesterday I had explained to you, if you want to work with an object, you should have a variable referring to that object. Now there are two variables referring to this object. There are two variables referring to this object. There are two. Understood? There are two variables referring to this object, and if you want to work with this object, you can use either b1 or b2. Okay. But here, if I want to work with this particular object, I have to use b only. That is the difference. So if I want to work with, get the values of 1, 2, 3, what will I use? b.w, b.h, b.d. If I want to work with 5, 6, 7, either I can use b1.w. b1.w is nothing but what? 250.w. b2.w is nothing but what? 250.w. So I can get the value, means I can work with this object. Understood now? Earlier b and b1 were two different objects. B and b1 were two completely different objects. This b1 was a different object, b was a different object. Any manipulation you did in b was not affecting b1. Any manipulation you do for b1 was not affecting b, because they are two different objects. Okay, but now what means, earlier you understood, earlier what was the case? This was the case. Any manipulation you do in b1 will not affect b. I change this value to 10, 20, 30, will it affect here? If I change any value here, will it affect b1? No, they are completely different. But now things have changed. b2 is referring to this, because I only gave the value. b2 is equal to b1. Now you might have a question, why should I give the value? Here it doesn't make any sense. But when you do call by reference, when you send the value as an argument, same concept will happen. So pay more attention here, so that your call by reference becomes very easy. Understood? So we are trying to assign the value locally. But only thing what will happen, b2 will be in another method now as a parameter. b2 will be in another method as a parameter. That's all the change will be. Okay. But let's see what is going to happen now. So then if I print SOP b2, what it will print? Here it was giving you error or null. Depends. If you have initialized to null, it will print null. Else it will give you error. But here it starts giving you the address. What? 250. Now if you print SOP b2.w, what is the answer you will get? 5. SOP b2.h, 6. SOP b2.d. Fine. It prints your 5, 6, 7. Same answer it prints. But I did not allocate new memory for what? b2. I did not allocate. But still b2 is working with this object, because it's referring to it. Are you understanding the concept of object now? Okay. Same way, box b3. Again, b3 is not referring to an object. But I'll say what now? b3 is equal to b2. The value of b2 is given to b3 now. What is the value of b2? 250. That is given to b3 now. Now two objects, 4 variables. Two objects are there, 4 variables are there. Two objects. This is one object, this is one object. How many variables are there? 4. What are the 4 variables? B, B1, B2, B3. But B1, B2, B3 are all referring to one object, this particular object, and B is referring to this object. Clear? So then next, if you want, you can print SOP what? B3, it prints 250. SOP B3.W you print, B3.H you print, B3.D also you print. It will print you 5, 6, 7. B3.D you print. It will print you B3.D also you print. It will print you same answer. It's not printing 0, 0 and all that. It's printing you what? Correctly. 5, 6, 7. So memory means I have created two objects. But the address of these two objects have been stored into 4 variables. But in that 4 variables, one is referring to this object, these 3 are referring to one particular object. Are you clear with this? Okay, just I'll remove space here. I'll write code here only because I need space. I'll continue coding this side now. So after that, I'll move this side now because I don't have space. Following now? So next what I do, see now, I'll try to do this now. Now very interesting. I'll try to manipulate the values in B3. B3.w into is equal to 2. B3.h into is equal to 2. B3.d into is equal, this is also a compound assignment operator. Compound assignment operator. Or you can directly, okay, see what will happen now? What is the value of B3.w? 5. Into 2 means 10. This will become 12. This will become 14. So where it is changed? Here. It changes here. It overwrites. So earlier what was 5, 6, 7 has now been changed to 10, 12, 14. This changed now, modified. And if you modify it in B3, if you modify in this object using B3, definitely it will affect B1 and B2 which are referring to this particular object now. But it will not affect P. Notice that. So either if you want you do modification like this, or in simple lines you write B3.w is equal to 10, B3.h is equal to 20, B3.d is equal to 30. Means what I am trying to tell is modify the value in B3. How you want to modify? Either you assign directly new values or you write the code like this. That is your wish. But if you modify anything there, it is definitely going to affect all the 3. Which one? B1, B2 as well as B3. Are you following this now? Are you following this? So what do you want me to take? This one or this one? 10, 20, 30 or this one? Anything will do now. Or if you want, I'll take this one only. So, assuming that I don't do this, simple I'll make. What will I do now? 10, 20, 30. So what will happen now? It becomes, anyway you can change the value, man. Directly assign it or you can do it like that. But if you modify it here, what is happening? It is affecting all these 3 variables. Now you print SOP B1.w, SOP B1.h, SOP B1.d. What it will print? 10, 20, 30. Following now? Yes or no? And if you print SOP B2.w, what it prints? 10, 20, 30. Definitely B3 will be definitely printing 10, 20, 30. Print that also and see. Are you clear with this? Are you clear? Now one more thing we'll see now. Very interesting. See this. B.w will print what? 1 only. Because B is referring to this memory. So if you change the value here, it affects these variables. But it will not affect this variable. Because this B variable is referring to this particular object. B1, B2, B3 are referring to this particular object. Getting it clear? Object is a very big concept. Clear? And this concept is true in C++ also. This concept is true even in C also. If you modify any content in your structure, what happens? Using a pointer, it will affect every globally, no? Same concept only. Okay, fine. Anyway, let's not think about that now. We'll focus on this. So this is done. Now one very interesting thing we'll do. B is equal to, see this now. I'll write B1 equals B now. What is happening now? I'll put it on the top here because I need space. B1 is equal to B. What happens? The value of B is given to B1, you agree? The value of B is given to B1. The value in B is not given to B1. The value of, understand the difference between in and of. The value of B is given. Of B is nothing but address. In B means 1, 2, 3. So the value of B is given to B1 and now B1 refers to this. It is not referring to this. And now what happens? Now B1.w, what it will print? Earlier B1.w was printing what? 10, 20, 30. Now B1.w will print what? 1, 2, 3. Check this. Understand how it works locally. Understood? B1.w will now print because it's referring to this address now. Very simple. See, this assignment operator is doing a very simple task. It assigns the value from right hand side to the left hand side variable. Whatever the value is on the right hand side variable. See, B1 was having a value earlier. What value was it having? 250. But this assignment operator is so powerful, it will forget what is the variable, what is the value held in the variable on left hand side. Simply it picks the value from the right hand side and assigns it to the left hand side. It does not care. Int a is equal to 5, int b is equal to 2, b is equal to a, it overwrites. Yes or no? Same thing it happens. You know this formula, no? Int a is equal to 5, int b is equal to 2, b is equal to a means what happens? B was having a value, it overwrites. This is primitive. Same thing happens with what? Reference also. Understood? So this is how it works. So b1 is equal to p. Are you clear with this? So fine. Now it will print. Fine. Now I'll bring it back. You print, after doing that you print and say b1.w, it will print what? 1, 2, 3. Okay. Now let it bring me back to the original position. What is happening now? Okay, sorry, one second. See, if you do like this, now if you want to work with 1, 2, 3, you got two options. Either you can use b variable or you can use b1 variable, because both of them are referring to this particular object now. And if you want to work with these values for this object, you can either use b2 or b3. Option is there for you now. Are you clear with this? Okay. Now let me bring it back to the original position like this. I'll not do that. Instead, ulta I'll do. What I'll do? B is equal to b1. Now what happens? The value of b1 is given to b now. Ulta will happen now. What is the value of b1? 250. So that is given to b. So b will now refers to this. Now all the four variables are referring to this object, and b.w will now print you what? 10, 20, 30. It will print you 10, 20, 30. b.h will print you b.w 10, b.h 20, b.d 30. Like that it will print. Are you clear with this? Now how will you get the value from this object? Gone. You can never get the value. And these kind of objects are called as dereferenced objects. You can never work with this object now. 1, 2, 3 value is lost for you. 1, 2, 3 value is lost for you. You can never work with this object. It is an unused memory now. So always you should have a variable referring to an object. Otherwise you cannot work with the object. It's something like you have got the TV and you have lost the remote. Understood? Earlier you had a remote and now you have lost the remote. Gone. You cannot work with it now. I got a watch without the key. I got an engine without the gear. Earlier you had, but you lost it. Understood now? And these objects are called as dereferenced objects. And in Java, you don't have to worry about releasing the unused memory. Releasing the unused memory. There's one subject. There's one subject called as how to allocate memory and how to release memory. Okay, I'm only teaching you how to allocate memory still now. Later on, I'll be covering how to deallocate the memory. But in Java, you don't have to bother. Deallocating memory is not at all the headache of the developer. In all languages, deallocating memory has to be explicitly taken care by the developer, and that's one of the biggest problem in all languages. But Java gives you a very refined approach for programming where it says do not bother about deallocating memory. Be free. Aram say you are writing your code now, go on writing. If at all there is an unused memory or deallocated memory, means if you want to deallocate memory or if there is an unused memory, but technically this is called as dereferenced object. These dereferenced objects are only called as unused memory. And we have to write the, means in other languages we have to write the code for deallocating this. But in Java we don't write the code for deallocating this unused memory or dereferenced objects. We don't write. So what happens in Java, in JVM, in the JVM, there is something called as garbage collector. There is something called as garbage collector. Something is there. I'll be explaining you more about that. Okay, later I'll tell, not now. So that garbage collector, what happens is, it will run periodically. We don't know when it will execute, but it goes on executing. Okay, when it finds that there are too many dereferenced objects in the JVM, that garbage collector will execute. Okay, or it will run. The JVM will send the garbage collector. Garbage collector is nothing but one program, man. It's one more built-in program which is there inside the JVM. So when that gets executed, what happens? It will come and collect all the dereferenced objects, not one, all the dereferenced objects, automatically it will clear. So in Java, we only bother about allocating memory, we don't bother about deallocating memory. If you want to allocate memory, go on saying new, that's all. Okay, but don't bother about deallocating memory. If there is any unused memory, JVM itself will collect it by sending the garbage collector. Brilliant, no? In C, what you have to do? malloc, dalloc. In C++, what you have to write? New, delete. Both you have to write. But here nothing, only new. No delete also, no dalloc also. What a privilege you get. They know that you are very busy. So they want to finish you programming fast. So that's the reason they give all this facility to you. Are you clear with this? So we'll be seeing more of this in detail later. Okay, don't bother about dereferenced objects right now. My topic is call by reference. We have to shift to that now. Okay, this dereferenced objects I'll be coming back and teaching you. Once full class I'll be talking on this dereferencing and all that. Clear? Okay, so let me bring it back to the original position. Means you cannot bring it back like this. Just I'll comment the code now. Let us bring back our code to the original form now. So B is referring to this particular object now. B1, B2, B3 are referring to this particular object. Are you all clear with this? So three variables are referring to this particular object, and B is referring to this particular object. Now very interesting. See, if I write B1 is equal to new box, what happens now? One more new memory gets allocated. Again you will have WH and D. Again you will have volume there. The values of WH and D will be 0. And B1 will now refer to what? It will now refer to this address. Print the address. It will print you something like 350. Now there are three objects but four reference variables. B is referring to this object, B2, B3 are referring to this object, B1 is referring to this object, and B1.w will print you 0. B1.w will print you 0 because B1 is referring to which object now? Print the address. You print the address. SOP B1. Print the address first. It will print you a new address. So what did I do now? See, for these reference variables, you can give a reference value of any box object. Understand that concept. For this B, B1, B2 and all that, they are reference variables. You can give the reference value of any box object. Either you allocate new memory and give the value to it, or give an existing memory to that variable. See, here I have allocated new memory and given to the variable called as B. But in this case, which one? I give an existing memory to B2. That's your wish. How you give the reference value to the variable is your wish. Allocate newly and give, or give an existing memory to that variable. That's your wish. So here what did I do now? For B1, I allocated newly and then I gave it. So now it changes. So it will be storing there now. And if you print SOP B1.w, it will be 0, 0, 0. And if you want, you can assign values. So that is the why I didn't assign the values using constructor here, because there also it will happen in the same way. If you change it, it will change it in that memory. But now it becomes more clearer here. What happens exactly when you are calling B1.w, B1.h, it becomes more clearer here. Clear? Any questions? I'll type this and show you now. Understood? Okay. So you have any questions here? You understand this locally now. Because see, the same thing will happen now. What will happen? B2 will become a parameter in a method. That's it. Here you will be having a question. Why should I say B1 is equal to B2, B2 is equal to B3? We will not do this. Okay. Generally this becomes important when you are learning call by value and call by reference. There, call by reference, this concept becomes very important. Are you clear? Okay. More things you have to observe. Now, here I am having box B. B is equal to new box. Just see this also. This part also you see now. Test T. One variable is there. Can I write T is equal to B? T is a reference variable. Can I give the reference value of B to T? No, yesterday I showed you this. It gives you error when? Compilation time. You see the benefit of it in Java. Because when I have a B as a parameter, box B, I cannot send test T as an argument. What brilliant feature Java is giving you. Java is strictly type checked. In C what happens? If you have a pointer as a parameter, you know how much problems you face, huh? That is why Java is strictly type checked. Understood? So I'll be explaining you this with program. Okay. So understand this basic first, and then I'll make you understand in methods and arguments and parameters. So this gives you error during compilation time. The same problem will be reported when you pass. You will be having a method now, M1 method, and your parameter will be of type box B. Can I send test to this? When is the error reported? Compilation time. But in C what happens? You will be having on M1 pointer P. Pointer P will have For this you can send address of what? Anything. Compilation will happen, execution will start off. But here, see what will happen. Here I have written the logic assuming that I am getting a value of type box only. But here in C you can't write the logic. You are getting the address to what? Very difficult. But in Java very comfortably you can write the logic, because whatever value you will get, it will be of type box only. So free it is for you to code. That is why Java is very strictly type check language. I show you with coding now. Then you will understand the benefit of all this. Okay. So end of the day we are learning what now? The topic is what? How to send user defined data as arguments. So if you send user defined data as arguments, it is called by reference. That is where we have to reach. But to understand that, all this is a process. Understand how it works locally first. Then you will understand call by value and call by reference. Clear? Shall I clear all this? You want any changes, you tell now, I'll do it here only. What if I do like this? What if I do like that? If you have any questions, you can ask. Because again I can't draw this diagram.
So B2 is equal to B1.
Yeah, here.
B2 is equal to B1. In the next line, B1 is equal to null.
B2 is equal to B1. In the next line, you'll write B1 is equal to null. Very simple. You tell now what will happen. B1 will refer to null value. That's all. With B1, you can't work now. You'll get null pointer exception. With B1, you can't work because you'll get null pointer exception. That is why I was insisting more on yesterday null. Understood? Any other questions? No questions? Again I can't draw, man. That's why. So we'll start typing now. I'll pick one class box which is already written. If you want, you can go with the constructor. You want me to go with the constructor, or I'll show you the same way I did it. Okay, I'll show you in the same way as I wrote there. Assign, I'll name it as a reference value demo. Assign reference value demo. Got it now? What are you trying to do here? Assigning the reference value. So that's how you give the names. And you can create a new folder. 20 reference value. Some short name you give, start working. Okay, so then next, see this. I'll write box B. We'll go step by step. Value of B is plus BL print. Will it compile? You get an error because B is not initialized. This is very crucial. You understand this problem. So what we have to do now, for this to compile, I'll give a value called as null. Yes. So now what happens? I've given a value null. So since you are given a value, it is assigned, value is there for it. No problem, it will compile and it will execute also and prints the value null. But it is not referring to any object, or object itself has not been created. So an object itself has not been created, you cannot work with that object. So next what I will do, if you want, you try to print p.w and all that, you will get what? Null pointer exception. W in B is H in B is D in B is. You will get null pointer exception. You are aware of this now? So you get the null pointer exception. Means 2 lines it has got executed. The third line it doesn't print. When it comes across b.w, it will not print and it will start getting the null pointer exception because your variable is referring to null. So you are trying to use a variable which is referring to null. You will get this problem. So do not try to use a variable which is referring to null value or which is having null value. So done. That was your mistake. So what will I do now? Now very interesting. B is equal to new box. This if you say, things change. And the default values will be what now? 0, 0, 0. The address it's printing, it's no more printing null now. So it prints, you do one thing, before this if you want to print, here on line you put, see maximum put SOPs man, will understand. If you are not understanding the code, what will you do? Put SOP, you will understand the flow. So first it is null. When I print value of B here, it is, when I print value of B here, it is null. After that, after this, B has got the reference value. Clear? So done. This is done. Next, what will I do? I'll give the value. B dot W is equal to 1. B dot H is equal to 2. B dot D is equal to 3. And after assigning these values, again you can print. Now it will print you 1, 2, 3. Go step by step, compile, execute, then proceed. Simply don't type the full program, compile and look for what? Semicolon. Okay, don't do that. So next what you do? The program size will become increased now. Okay, in C to code 2 lines of code you are struggling so much. See now how many lines will code today? Box B1 is equal to what? Null. Correct? Huh? So okay, I'll do one thing, I'll copy paste this entire thing. This box B1 is equal to null. Value of, same story will begin here now. Value of B1 is what? On new address. B1 is equal to new box. Value of B1 is, first it was null, now it will print what? A new address. Then value of W in, sorry, B1 is plus what it will print? B1 dot W, B1 dot H. So I'll give what values? 5, 6, 7. In this object I give the values of 5, 6, 7, and if I want 5, 6, 7 I have to get what? I have to print it as B1.W, B1.H and B1.D. Correct now? All this is correct. So let's see the output now. Perfectly what we expected. B is null, address. B is null, address, first initially it is 0, then I'll assign it is 1, 2, 3, then again B1 is null, address is there, it is having default values of 0, I assigned, correct, everything is perfect. But now next, we'll go with B2 now. Box B2. Okay, B2 is equal to null. Can I work with B2 now? No. And if you print value of B2 is what it prints? Huh? Null it prints. I cannot work with B2. Yes or no? What will you get if you try to work with B2? Null pointer exception you will get. Okay, let's see the last output now. Value of B2 is null. Can you see this? Value of B2 is null. Focus on that now. So it's printing null. But if I don't initialize, I get a error. I cannot work with B2. Done now? Okay. So if you want, we'll assign it with null value. But next line what will I do? See this. This is very interesting. B2 equals B1. So for B2 I have to give a reference value. reference value of which one? Box object. Yes, I am giving that only. But this time I did not allocate and give. See, for a reference variable, you can give the reference value in two ways. One by allocating new memory, or by giving a existing value, existing memory. That's what I did. I gave an existing memory to B2. And I am not, again I am repeating, I am not giving value in B1, I am giving value of B1. Value in B1 is 567. Value of B1 is that address. Clear? So now what happens? You print now. What it will print? It will print address. And afterwards I will print what? The values. Value of W in B2 is, clearly you can see now, B2, B2, B2. Done. Compile, and now you can see. B2 I did not allocate memory only, and you can notice this address, B1 address and B2 address, they are ditto to ditto same. This B1 address, B2 address same, and values are also same. B2 will not have any default value because B2 is directly referring to an object. Clear? So then next, if I want, I can go for what? B3 also, no? B3 is equal to null. Then what will I do? B3 is equal to B1 also I can say, B3 is equal to B2 also I can say, my wish. So now value of, here you can print, B3 is B3. Done. Now you can see B3 what it prints? 567 again. Address is same now. Address is same. What is the address? See, B1 address, B2 address, B3 address, all are same. Now I will manipulate in that object using any variable. I can use B1 or B2 or B3. I can manipulate. But if I manipulate there, it will not affect B. Yes or no? They are two separate objects. So only when you manipulate in an object, it will only affect the variables which is referring to that object. It will always affect the variables referring to that object. So now I will manipulate. What will I manipulate? B3 dot W into is equal to 2. B3 dot H into is equal to 2. Anything you would modify, man, that's your wish. B3 dot D multiplied by is equal to 2. After you modify, in B3 values are what? Changed. That you know. But definitely it is changed where? In B2 also. And definitely it is changed in B1 also. So we will focus on the last 9 output. 9 output will focus because there are 9 statements. 3 related to B3, 3 related to B2, 3 related to B1. So if you manipulate anything there, it is affecting only, see, 3 outputs, 10, 12, 14, 10, 12, 14, 10, 12, 14. But I print B also. This value in B also I will print. It will be 1, 2, 3. There it has not changed. In B we have not modified anything. So if you modify in that object, it is affecting only those variables which are referring to that object. Are you clear? Okay. Now very interesting. We will see what now. I will write B1 equals B now. What am I doing now? The value of B is given to B1 now. The value of B. What is the value of B? 150 or whatever that address. That is given to B1 now. B1 will print what now? 1, 2, 3. Earlier B1 is printing what here? Here it is printing 10, 12, 14. Immediately after this 1, 2, 3 you see now. What will B1 print now? Here you can see it will print what? 10, 12, 14. After I do this operation it will print 1, 2, 3. See, notice now B1 output you focus. See, B1 is printing 10, 12, 14. The same B1 is now printing what? B1 was printing 10, 12, 14. After I assign B to B1, it is printing 1, 2, 3. Yes or no? Okay, but if I do ulta, and now I can work with 1, 2, 3 with 2 objects. Either I can use B or B1. And if I want to work with 10, 12, 14, I can use B2 or B3. 4 variables, 2 objects. But 4 variables, 2 objects. 2 variables are referring to one object, other 2 variables are referring to another object. But now B is equal to B1, what will happen? All 4 referring to same object, and that becomes which one now? Now I can't get 1, 2, 3. Gone. How will you get now? Nobody is referring to that object. So what will happen now? I can never get that value. Initially it will print. When it is referring, you can get the value. See, when it is referring, you can get this value. But after you assign B is equal to B1, after you do this operation, B is equal to B1, you can never get the value of 1, 2, 3. That object has been dereferenced and it will be automatically destroyed. You don't have to worry. How it will get destroyed and all, I will be telling you later. Okay, but it will be automatically destroyed. You don't have to worry about this. And one more thing, we will come back. We'll not do all this now. Okay, I'll show you. B1 is equal to B. So B1 was printing what value now? 1, 2, 3 now? I'll bring back like this. B1 is equal to B. What will happen now? It will print 1, 2, 3. Earlier B1 was printing what? See, first B1 is printing 5, 6, 7. Here it prints what? Carefully notice. Here B1 is printing 0, 0, 0. Then it prints 5, 6, 7. Okay. Then B1 will print what? Here again it was printing after modification 10, 12, 14. Then after assigning the value, what it prints? 1, 2, 3 last. So like this values are changing. Fine. Now what I'll do, I will write B1 is equal to new box valid. Now B1 will totally refer into another new object itself. And if you want, you can print the address. See, it's better you code and understand all this. Value of B1 is plus B1. Last you see it will be a different address. I'll print value of B here also. B1 here also. Value of B1 after assigning B. Understood? Value of B1 after new object. The value of B1 will go on changing. So initially, see, value of B1 is something like this. What is the address of B1? Box at the rate of ADDF, something like that. Okay. Then when you come down, we have written somewhere here, after assigning, it becomes what? You will get the address of B. This was the address of B. Lastly, when I say new box, one more new object has been, memory has been allocated, it's printing that. And in that address, values will be what? 0, 0, 0. If you want, you can print and see. Clear? If you want, you can print and see the values in B1 will be. And in that memory also you can store some values. B1.w you can store something like 55, 66, 0, 0, 0 is there. So 3 objects, 4 variables. Any questions here? Understand locally. If you understand locally, call by reference becomes easy. Simply don't neglect these basics. Your problem is basics only. You don't know how to work with assignment operator properly. You actually neglect this operator to such an extent that finally you will not understand any code only. Such a powerful operator it is. This is actually, in fact, what I tell, caution mark. When you come across this line, think twice. What's happening? Value from right hand side is given to left hand side. Whatever the value. If it is a primitive value, it will give that value. If it is reference value, it will give that value. That's it. Blindly it will give the value. But provided it is compatible. And Java takes measures to check that compatibility while compilation. That's why Java is strictly type check language. Now if I have a class test, if I try to give it to T, will it work? Let's see that. That I've shown yesterday, no? Class test. Int y, I'll just write on void m1. Hardly I'm writing any code here, just to see this. Now I can declare a variable of type. See, to use a user defined data type, first define it. Now, b is equal to null, fine. B is equal to new box, okay. But test t is equal to null. T equals b. When will I get the error? You know, compilation time. Notice, that's one brilliant part of Java. This is not allowed, and this is such a beautiful error. This will help you to develop your such good programs. Later on, you'll understand. Okay, Java is strictly type checked. It checks for data compatibility. Only if the values are correct, then only it will compile, and during runtime it will execute. So it is trying to avoid maximum errors during runtime. Maximum. In C and all, we cannot detect all this, and we start getting problems during runtime, and you simply go on restarting your computer. Understood? Here it does not make such big difference to you. I'll show you what big difference it comes when you are talking about call by value and call by reference. Yeah? Shall I continue with call by value and call by reference now? So I'll show you how to send the object as a argument. It is very simple now. Shall we see it now? I'll show you how to send an object as an argument also, as well as a return type also. We'll see. Both we'll see. But first I'll show you argument parameter, then I'll show you return type. We'll take the class box itself, int w h d. This time I'll use a constructor. You can have your volume method. You now write the code for volume method. Okay. Similarly, I'll have one more class called as test, and I'll have int x, y. I'll have one constructor for test also. X is equal to p, y is equal to q. I show you how to send two user defined data type as argument. That's why I'm designing two. Then I'll have one void show method, which will print what? SOP value of x and y is less x less y. Simple. Class test and class box, two classes are there. Let's see how to work. See, I'll have one method here, static void m1. You remember we had written so many methods, and you have not forgotten primitives now. Primitives means what? Int a is equal to 15, int b is equal to 20, int x, int y. Do not forget the basics. Is equal to 0, 0, x is equal to a, y is equal to b. I modify x and y, it will not affect a and b in the same scope. Later on I showed you x and y coming out into arguments. I'll give the value of a and b to x and y. If I manipulate x and y here, it will not affect a and b. Are you comfortable with this example? So in call by value, what happens? If you manipulate anything, it will not affect. But let's summarize this actually. First you understand local. Local is clear for you now. If I manipulate anything here, first let's talk about primitive. Revisit the program. X into is equal to 2. Y divided by is equal to 2. Now SOP A, B, X, Y. So what is the thing I have done here is, there are 4 variables in the same scope. Understand it technically. There are 4 variables in the same scope. X and Y are in the same scope. A and B are also in the same scope. If you want to give the value from one variable to another variable in the same scope, you use the assignment operator. But once you assign the values, you modify X and Y, it will not affect A and B. But that was not the case with B1, B2. There you are assigning what? Reference value. You manipulate anything in B1, it was manipulated in B2, B3. Understood now? So there also it was the same story. B, B1, B2 were all in the same scope. Yes or no? They are all in what scope? Main scope now. B1, B2, B3, B4 were all in the scope of one method. Okay, and I was assigning the values with assignment operator. Here also same thing happens. Are you clear with this? So if you understand this now, only thing what I like change now is this x and y will come as parameters now. M1 is the method. Now x and y are variables in another scope. Yes or no? Now how will you assign the values from one scope to another scope? Argument and parameter. No other option. I don't have the assignment option here. So I'll call M1 method and send A and B as arguments. So that value will be copied into X. Whatever the value you give, value of A is given to X, value of B is given to Y. Whatever the value, blindly it will assign. And I manipulate anything here. Will it affect A and B? No. We have seen this program. Okay. But what was my intention? I wanted to give the value stored in A and B to X and Y, which was in a different scope. So I sent it as argument. And after manipulating, if we print A and B here, it will be printing same. But 15 and 20 would have been changed. Same thing. Are you clear with primitives? Let's proceed to user defined now. We have got two user defined. I'll be sending them as argument now. Static void M1 box Z. Z is a parameter of type box, valid code. So your parameter can be primitive types also, array type also, or user defined type also. Any data type can be used as argument and parameter. But to define this, I am not using pointer like C. What am I telling? Z is a variable of type box. Is Z referring to any object? Is not referring. Fine. We'll print and see. SOP z.w, z.h, z.d. So this is the case. Now if main method wants to call M1, it should send an argument now. Otherwise it will not execute. A method can be invoked only when you send the correct argument. I'll send B. Now I'll run the program. What will happen? Null pointer exception I'll get. Because see, whatever the value is there in B, it is given to Z. So it's something like you want to assign the value in B to Z, but Z is in a different scope. So since it is in a different scope, what will I do? I'll send it as an argument. It's very simple. I want to give the value of B to Z. Value of B, not value in B. Value of B to Z. I'll give it like this. But it will print null pointer exception. You do like this, sir. What will you get? Uninitialized. Variable might not have been initialized. Understood? Anyway, this is okay. So if you want to this method to execute now, compulsory you have to initialize B and send now. Otherwise it will not work. How will you initialize B now? B is equal to new box of 1, 2, 3. Creating an object. Understood? And then I'll call M1 of one second. You print all the values. SOP, B.W, B.H, B.D. What will it print? 1, 2, 3. I'm using the construct. So what has happened now? One new memory has got allocated. You got WH and D. You got the constructor here. And you got the volume method. And B is referring to this address 150. Valid. And you print B.W, B.H, B.D. What it will print? 1, 2, 3 it prints. Are you clear? Next I'll call the method. Which method I'll call? M1 method. I need space, 1 second. I'll call M1 method and send B as argument. Static void M1 box Z. SOP z.w, z.h, z.d. Can you predict what is the answer? You are giving the value of B to Z. Now Z also will refer to the same object. Z.w will print what now? 1, 2, 3. Understood? Supposingly I send an object with 10, 20, 30 values. This time what will z.w print? So means what object you, means it depends now. Whatever values you keep in your object and send, whatever values you keep in your object and send, this method will receive that value. So now I am showing you how to send multiple values. Yes or no? You are seeing what is the advantage of sending an object as argument. We can send multiple values. But here heterogeneous type. Here in box all my data type is same int, but one could be int, one could be double, one could be boolean. No. That's the advantage. So how easily you can send C? For C you struggle, pointer, int, structure and all you will think. To do this in C you die actually. Understood? But here it is so simple. Concept is same. The concept of C, what C is trying to give you and what Java is trying to give is same. But there it is so difficult, but here it is so easy. Concept is same. End of the day you have got a user defined data type. Why do you have a user defined data type? To store values. Why do you have a user defined data to store values of heterogeneous type belonging to one entity? So instead of sending 4 values, 5 values, 10 values as arguments and parameter, all those things I'll keep it in one user defined data type and send it as argument. Over now. And I can use it here. Now how you use your wish? You use it. But if you manipulate, things are different. Use it. Don't try to manipulate. But if you manipulate, it will be affecting there also. So here you print SOP Z. It will print the same address of B. So this is purely showing you what? Call by reference. It's purely call by reference now. How does Java work? Call by value or call by reference? Both. Depends on the argument you are passing. If you are passing primitive type, call by value, and if you are passing user defined type or derived type, call by reference. Array also I passed and showed you. Arrays, how to send array as an argument. Now I am showing you, but array will contain homogeneous data type. But user defined data types contain heterogeneous values. Arrays contain homogeneous values. User defined data type contain heterogeneous values. That's all the difference. So you can pass. Okay, but once you pass it, it will be called by reference. And one more thing, see, we tell call by value, call by reference. You don't get confused about that too much. Simple it is. Basic is what value is there in the variable, same value will be given here. That's it. If reference value is there, reference value will be given. Primitive value is there, primitive value is given. What is there now? Over now. You don't have to worry too much about that. Whatever value is there in B now, you print and see SOP B, same value will be given to Z. Nothing more. If it is primitive, it will have given the primitive value. If it is user defined, it will give the reference value. That's it. Whatever the value. Okay. Now I will manipulate z.w into is equal to 2, z.h into is equal to 2, z.d into is equal to 2. What happens? Sorry, we had created a box object with what values? 5, 6, 7, no? Or 1, 2, 3. So when you created the object, here, this line, wh and d was 1, 2, 3. Now when you send it, see, when you print, it was printing 1, 2, 3. When you send it and modify, okay, here you print SOP z.w, z.h, z.d. Will print your 2, 4, 6. 1 into 2 is what? 2. So now what happens? If you modify here, it is changed here. Now once the method completes execution and control comes back, now you print SOP b.w. What will it print?
1, 2, 3.
So go and work with your basics. 2, 4, 6 it prints. Understood? How it will print 1, 2, 3 now? This is where your problems start off, because you are not working properly. It should print 2, 4, 6. Yes or no? All this while, what did I explain you, man? B1 is equal to B2, B2 is equal to B3. Why did I explain so much? After telling full story, now you are telling, some people are telling what? 1, 2, 3. How it will print 1, 2, 3? If you modify in that object, it will affect both the variables, because both are referring to the same object. Only thing is, scope is different. There B1, B2 were in the same scope. Here all of them are in the different scope. That's it. Any questions you are having here? Call by reference is very important. Work on this. To understand this, that is very important. Clear? Similarly, I can have M2 method, static void M2. Parameter can be what? Test Z. Can you write the logic for this? create an object of test. Create it here. See, this is main method. I continue here. Test t is equal to new test of 5 and 6. M2 method, and I'll send t as an argument. Over. That will come to what? M2 method. This is another method. There are 3 methods in class demo now. Main, M1, M2. So from main method I'll send t as an argument. It will come here. How you want to see one test object has been created, and in this the instance variables are x and y. There is one constructor and there is one show method. So what is the value of x and y? 5 and 6. Now it will come here. SOP z dot x, what will happen? It will print you 5 and 6. Fine. But if you modify, it will modify there also. Where it will modify? Now z is also referring to this one. See, there are two z, don't get confused. Scope. This z is of type box, this z is of type test. Or if you are getting confused, change the name, test p, over. Understood? Now p will refer to what? This one. So now you print p dot x, p dot y, it will print the same value. Which one? 5 and 6. You manipulate, it will affect what? T also. Because t and p are both referring to the same object. Like this you can send any user defined data type as argument. Clear? So what is the advantage of sending user defined data type as argument? Multiple values. But in using a single argument you will send. So now see, for M2 method, what is the argument I have to pass? Of type test only. For M1 method, what is the argument I have to pass? Of type box only. You try to pass, you call M1 method with T, error. You call M2 method with B, error. When? Compilation time. In C what happens? It will compile. During runtime you get errors. So here your argument and parameters are checked during compilation time. Understood? What is the benefit? See, when you are writing the logic in M1, you are purely assuming that you are getting an object of box and writing. It's correct. So your logic is what now? Based on box. Similarly, what is your logic in M2? Based on test. Means the value stored in test, and you work with that. Suddenly some other argument comes here, your logic will go wrong now. And Java will not allow you unwanted arguments during runtime. It will restrict it at compilation time itself. It will not compile only. What a benefit now. That is what you mean by data compatibility, and this is what is called as robustness. Java is very robust, they say, because of type compatibility. Initially, all of you know definition wise, Java is strictly type checked, Java is strictly type checked, definition wise. Programmatically, none of you knew what was the meaning of it. And it is taking me so many days to make you understand what do you mean by type checking. Theoretically, you know, oops. Theoretically, you know Java is good. Theoretically, you know everything. But when it comes to practical coding, you fail. This is how they have designed it. Clear this? I'll type and show you this and we'll complete the class. Clear? Any questions you are having here? Tomorrow I'll return. Remember, return type becomes what now? If you want, you can return also. Now I can return multiple values now. You had a question. How to return multiple values? I said, I'll show you one method here. We'll finish off with return type also. M3 is the method box. So when you call M3, what should be the, you don't have to send any argument, but return type of M3 should be what? Box only. Compulsory it is. So write whatever code you want here, but finally what should I do? Box B is equal to new box. You create an object 10, 20, 30 and return, what will you say? B. B is one data type now. I'm still following the rules of what? Java. I can return only one data type, but it is one user defined data type. But in that one user defined data type, I am having multiple values. So now if your main method calls M3 method, see here, I'll have box B1. Is B1 ready for usage? It is not ready for use. But when I call M3 method, object gets created. The address of that object is given to which one now? B1. And SOP B1.w will print what? 10, 20, 30. It will definitely print me 10, 20, 30 because what has happened when M3 is called, when M3 method is called, one object gets created, B. It will have values of what? 10, 20, 30. Address might be 150, 250, 350 something, don't worry. Return B means you are getting what? Reference value. The value of B is given to which one now? B1. And you print SOP B1 here. Same. You print SOP B here. Same. Before returning you print. It will be having the same address. And then you print. Return B. You print even B.W. It will be 1020. Same address is given to what now? B1. So I am returning multiple values now. So tomorrow I will use so many methods and will be returning, means sending so many arguments. All these concepts will become very clear to you. More examples I will give you. To send what? Arguments and parameters. So we are struggling to write logic or sending arguments and parameters. In Java only if you are telling it is difficult, imagine in C what will happen now. In Java only if you tell so much of type compatibility is there, everything is there, you are telling Java only it is difficult. Imagine other language, not telling C now. How will you become a programmer then? So learn to send first what? Arguments and parameters, which you neglect so much. And for understanding arguments and parameters, first basic more than that is assignment operator equals. Whatever you can assign, that you can send as argument, simple as that. More than that, nothing else. It's not rocket science. Understood? You think argument parameter means big subject. No, you should not tell that. Why are you telling argument and parameter is easy or difficult? If you tell argument and parameter is difficult now, you should tell what? You have not understood assignment operator. This operator you don't know properly now. And if I tell you now you don't know this assignment operator properly, what will you tell? No, I know very good. But actually you don't know this operator. Work hard on this assignment operator. What you can assign locally, same thing can be sent as argument, return type, parameter, return type. That's it. Clear? So here we are seeing how to return a value. I call M3. See here B1 was not initialized. But as soon as this method gets executed, B1 is ready. Yes or no? So like for B1, what is the thing I am trying to do? Trying to assign a value. What value? Reference value. Same thing. Assignment operator, what it will do? It will get the value and assign it to B1. And again, when you are calling the method, no need to accept the return type. It's optional. If you don't accept, you will lose that value. That's it. Are you clear with argument, parameter, return type? Only we are seeing now user defined type. If you work with arrays, this is much similar. Okay. Shall I clear all this? See, tomorrow I will be showing you a lot of combinations. Your argument will be of type primitive, return type will be user defined, argument will be user defined, return type will be primitive, all that I will show you. Okay, but before we proceed to that level, this user defined data type should be perfect. Okay, once your user defined data type is perfect, then we can send and do anything now. Anything you can have. See, you can signature of the method can be like this also. Example I am telling. M1 method. Int A, double D, box B, valid. We'll now have to send now. And why I am stressing so much on arguments and parameters is, why can you guess? Because we work with built-in libraries. We don't write any code there. And you should know how to call existing methods. And you should not get compilation errors that time. Understood? So as soon as you see the signature of parameters of the method, you should know what are the arguments you have to send. Otherwise compiler will report error and you will start seeing what? Searching for semicolon. Don't do that. So practice hard. Java we don't write logic. Just send, all logics are ready made for you here. Just you have to send the arguments and parameters. Do not worry about writing logic. What logic you want, it's there. It's such a easy language. So I have two classes, class box and class test. So class call by reference demo. So done. Next, we'll have some methods here. So first we'll create the objects and work. Box B is equal to okay, I'll bring a constructor here. We can have a constructor for test also. So I'll create a new object by passing 1, 2, 3 as arguments. And if I print b, b.w, you know the story, it print an address and it print the values in it. That is 1, 2, 3. This is not at all a problem for us. But I want to send b as an argument now. To send b as an argument, I'll write on method static void, sorry, not void now, because we have to return what? Sorry, void. Return type is void, method name is m1, parameter will be of type box z. Done. So now after passing, I'll just print and show you what happens. Step by step you go. Value of z is control 1 compiles. I didn't call that method, sorry, I'll call it, and I'll send b as an argument. Okay, but if I see I'm sending b as an argument, after sending also I'll print. The values will be what? Same. Value of w in b after m1. Done. So I'm just sending z, that's it. But see how learn how to send arguments. I'm sending perfectly, it compiles, perfectly it prints, and in sorry, I didn't change the value. Okay, I printed. See, first in b it is 1, 2, 3. Address of z is same. In z also values are what? Same. Value of b and value of z is same. And after calling this one, it is still the same value. No, nothing has been modified. So don't try to modify. But if you modify, it will affect. Okay, see, caller method will give the value to callee method. Callee method has to write the logic using that value. Okay, but callee method generally will not change the value. But if it changes, it will affect because it is called by reference. Done? So then this is done now. So now, see, I'll send 1, 2, 3 I send. Now, 10 or 11, 12, 13 I'll send. Now what will be the values in Z? So this is an open parameter. You can send any object. Box with 10, 1, 2, 3 or box with 11, 12, 13. See this, now it's printing what? 11, 12, 13. So what you are going to just send the reference. Value depends on what value you kept in the object and send the reference. Clear? Fine. We'll bring it back to 1, 2, 3 only. And now we'll try to modify here. Clear? So just I'm showing you z dot w into is equal to 2. Z dot h into, sorry, is equal to so after changing the values, again if you want to print, what will be the change value? Inside anyway it will be changed, but definitely it will be affecting B also there. Here also it will change. See this. First it will be 1, 2, 3 here. Later on it will be 2, 4, 6. Both the places. So initially in box 1, 2, 3. Then the set starts. M1 starts of execution. It is 1, 2, 3. There only 2, 4, 6 it is manipulated. And afterwards in M1 it is 2, 4, 6. It is called by reference. But this will not happen with primitives. Clear? Any questions? Are you clear with this? Okay. Now what I'll do is I'll try to send. I'll create an object test t is equal to new test, and I'll put values like 10 and 20. Object is created successfully, so it will compile. All that not a problem. But in M1 I'll try to send t as an argument. What am I trying to do here? Notice this. Here I am in M1. What am I trying to send? T as an argument. When is the error reported? Compilation time. What brilliant, man. Understood. Java is strictly type checked. What benefit you are having? See this. Because if it has compiled during runtime, all problems will happen here. No. Java will not allow that. Understood. In other languages, I am not telling C and all now. It will compile. It will execute. During runtime, you start getting the problems. So Java, maximum it avoids problems during runtime. Are you clear with this? So if at all I want to send t as an argument, what should I do now? Either change parameter here or write another method. So I'll write another method. Understood? So because I want to send what? Test as an argument. So now let's see now. So this is how you go on writing. Test t is equal to, you can write it in a single line. Okay. Then you can write on M2 method now. I'm writing M2 method in the same class. Which one? Main class. M2 parameter is of type test. Change the name p. It's a local variable. That z is different. This is different. Okay. If they are in different scope, you can give the same name. We have done now int a, double a. Same way. We can give the same names. Okay. Now I'll print value of p is plus p. Same way. Value of x in p is p dot x, p dot y, and if you want you can modify here also p dot x and y, no? X p dot y. If you want to manipulate like that, or you can assign totally different value, like something like 11 and 22. That's your wish. What value you give, that's your wish. So now here we are creating a test object of 1 second. You can manipulate like this. I'm creating with values of 10 and 20, and I'll print the value here. If you want, you can print it value of t is plus t. Same story here, man. T dot x, t dot y. Sorry, x in p is, y in t is. Now I can call M2 method and I'll pass t as an argument. Then after calling, also I can check the value. It will be modified here also. Yes or no? Value of x in t after M2. If you want to modify else, leave it. Just I'm showing you. So now you can see very clearly. Compiles, execute. Or I will do one thing. I will not call. I will comment of everything of box. Work with only test. It's simple now. You'll understand. Clear? P is this address, X and Y is so and so. Means M2 execution starts off. P and Y, X and Y is initially 10 and 20. I'll modify, after modification it is 11 and 22. Then after M1 is invoked in main, you can see the value is changed to 11 and 22. Same way. Are you clear with this? So I showed you how to send user defined data type as arguments. Now we'll see how to have a return type now. So return type will be what? Box. And the name I'll give is M3. Parameters can be anything. Tomorrow we'll talk more parameters. But now compulsory, you write what code you want here. Return type should be box. Write whatever you want. Write 1000 lines of code. That is secondary here. But compulsory or return type should be box. So box, I'll give something like box B is equal to, or we'll take some name like box L is equal to new box of 9, 9. This is L. Okay, I'll name it as M, which will be more clear. So end of the day, what should I do now? Return M, means a variable of type box. If you want, you can print value of M is, all that story will continue now. Value of M is value of W in MS. Correct? Huh? Now see this point. Sorry. Value of B is what now? Right now? Null, no? I'll comment off everything. Test also I'll comment. Value of B is what now? Null, no? See, how will I initialize it? Simply I'll say what? B is equal to M3 over. And after that, you can print all the values. Finish now. It is initialized now. M3 will be executed, object gets created, that reference value will be given to B. I'll print the address here. But what are we doing? We are returning a user defined data type. We are returning a user defined data type. See this now. Non-static method. I'll make it as static. Don't worry what is static. Topic is pending. Monday we'll see what is static. Understood? Are you clear this? So now what happens? B is null initially. Then I'm calling M1 method. In M1 you can see a new object has been created. I'll return it, and now in B the values are 999. You can return a user defined data also. Yes or no? See, this is the output. Any questions here? So now see, you can send user defined data type also, you can return it also. Any data type you can send as argument, any data type you can return it. Advantage of sending user defined data type and returning user defined data type is we can send multiple values, heterogeneous values, and we can return also multiple values. But we still follow the rule of Java. We are returning single value. It is of type box. But one interesting thing you see now, if I want, I can see now, if I say return m.w, the return type becomes int. That also you notice. m.w, I am returning what now? Primitive value. Actually, in this method M3, there are 4 values. M is a reference value. WH and D are primitive values. Among the 4 values, which value you want to return, you decide. If I want to return the value in W, m.w, return m.h, return m.d, correct. That time return type becomes int. But if I want to return box only, then you have to return the reference value. 4 values are there. So always when you want to return, you should know how many values are there in your method and what you actually want to return. Clear? Are you following now? B.w is what? Primitive, no? Print it. 10 it will print. Or what? 9 here. It is printing 9 here. Sorry, m.w is printing what here? 9. I want to return a 9 value. 9 is a value of type what? Int. So return type becomes int. Now what you should accept here? Here it will not be B now. See here, incompatible type. So it should be of type int now. Int x valid. Now print SOP x. It will print only 9. But b.w and all error now because it's still null. Understand? Null pointer exception will get. Are you clear? Just practice like this. More methods I'll show you tomorrow. More methods you know to write. Means here logic anybody can write here. But if you want your logic to execute, what is required? Value. So learn to supply values to methods first. Understood? Learn to supply values to method by sending arguments and parameters. It is a big subject which still it will continue. It is not as easy as you are thinking. Understood? In C actually this is very difficult. In C also, C++ also, because the concept of pointer comes and they call it as address and all. Here we purely call it as what? Reference variable. See, this is a reference variable of type box. This method will accept a reference variable of type test. Very clear it is. But in other languages it's very complicated. Understood? And since you are not practiced this in programming, that is why you are finding it difficult. In any language you have to learn this. And in any language you have not practiced this one. Directly learn it in C. It's not that you have to go and learn it in C and come back here. In C it is difficult to learn, I am telling you. You know the basics of C, that is more than sufficient here to learn what? Java. Normal basics. What normal basics? Int A, int B, that is sufficient. Rest all you can practice it here itself. Clear? Any questions?
So now if we assign B value to one more box type variable, and then that value name will become dereference.
Which one? Why it will dereference, sir?
Because the termination will be over, so M won't be existing anymore.
See here it will get dereferenced. This question is here the object will get method completes execution, M is destroyed. But still that object is referred by B or no?
If I assign that to a different box,
Then it will get dereferenced. We'll be talking about dereferencing later. Dereferencing we'll talk later. So what I am talking right now is call by value, call by reference. I am not talking about dereferencing, dereferenced objects. That is not my topic today. Okay, but by chance if I don't accept it here, this is dereferenced. This object here will get dereferenced. So I'll call M3 method now, but I'll not accept the value. This is dereferenced now. Like that, many ways are there how dereferenced objects get created, but we don't care about what? Deallocating the memory. In Java we don't care about that. I'm calling M3. Okay, but I'm not accepting the return type. So M is means this object gets dereferenced. As soon as this method completes execution, object is there, but variable is destroyed. Once variable is destroyed, now nobody is referring to that. It is a dereferenced object. It will be automatically collected by garbage collect. There are many ways how a dereferenced object gets created. One, if I say only new box, dereferenced. Then I'll say B1 is equal to new box, B1 is equal to null, dereferenced. B1 is equal to new box, B2 is equal to new box, B1 is equal to B2, dereferenced. A local variable like this, dereferenced. But anywhere we don't bother about deallocating memory. What a brilliant feature now. The same thing if you try to code in other languages, you have to bother about what? Allocating also, deallocating also. Where and all you will keep track now. Where you allocated you have to keep track. Where you have to deallocate you have to keep track. More than writing code, you are only bothered about allocating memory, deallocating memory. That is your old tradition. Always when I write on program, what will you ask? Memory, memory, memory. Without memory you can't code only, no? Means without thinking about memory you can't code. First code, man. How much of memory is required will supply. First I will supply. I have little money. Understood? If your program is really good and I can't supply money, more money will come from Narayan Murthy. If your program is still good, Narayan Murthy also cannot fund. Bill Gates will supply. First write application, then think about memory. Hardly you write one line and you think about what? Memory, 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 memory. Hardly one variable, int I, sir, 4 bytes, sir. Means what will I do? Hardly you are getting the output. So first write application. How much our memory is required today? They can supply, no problem. I told you, from low level to high level. Bill Gates is there. sitting right on top. He'll purchase your application. First write the application, but without writing the application only, int I, first line only, 4 bytes, what should I do means, your program only will never complete. Yeah? So practice all this, call by value, call by reference. I shown you how to pass user defined data type as arguments. This is very crucial. Next class will be sending more things. As I told, the signature. The parameter will be one int, one double, one box. Return type will be test. All in a single method. If you want, you can see tomorrow. How you want, you tell signature. I'll return it. Tomorrow you should ask me questions like this. Sir, my signature is like this. M1, int, boolean, test. Fine. Return type should be box. You should know how to write this now. Understood? Anything given, you should be able to write. Okay. So writing is one part. Later on, when you use library, in the library also there are methods which will ask for arguments like this and which will be giving you return type like this. That time you should know how to work. So that's why basically I am covering that. So if you want to call this, supposingly I write this method, you should send an argument of type int, send an argument of type boolean, and send an argument of type test. And you can accept a return type of type box. Try all this if you want today. I have shown you 3. Tomorrow anyway I will be showing you this. But you can practice. Don't bother about writing logic. Try to send values. That's all I am sending. Logic anybody can write. It's simple. And moreover we don't write logic. That also I am telling. Okay, why we don't write logic? Java is having a library. Understand that. Why other languages don't give rich library? It's not platform independent. Java language is platform independent. So that's why they give you very powerful libraries. Understood? Any questions? So whatever code is required for the developer, they know. They have got years of experience. 25 years of experience Java has got. Anywhere Java developer finds difficulty, they'll release one code for it. They'll release. How many versions are there? So many built-in classes are there for you. And all those built-in classes are containing what? Int I, int j. They don't contain int I, int j. They contain terrific coding. We only bring that code into existence by creating objects. And we work with the complexity. How? Reference variable. String s is equal to new string. That's how you work with built-in classes now. Finished. Bring the code into existence, work with complexity. S dot, what you want. So that's why I'm showing you how to work with objects, because later on we have to move to built-in classes. Such a simple language. Full luxury here. Understood? But unfortunately you are not understanding how to enjoy the luxury. Luxury is there. Everything is there here. Okay, but you are telling where is luxury? What should I show you now? Understood? I am taking you to a 5-star hotel and telling you do what you want. You are asking me, is this 5-star hotel? How will I prove that? You should only feel it. Yeah? Okay, that's it.